So you have to listen to me for one more presentation, but we're in the home stretch. So I'm going to talk a little bit about viewport display configuration and some experiences we've had with that in NVIDIA, and I'll explain more about what I mean by that. So I'll mostly talk about challenges we've faced around fixed resolution displays, flat panel scaling, overscan compensation, and aspect ratio scaling. So for history, as everybody knows, back in the old days, we had CRTs that were driven by VGA. The resolution and refresh rate were defined by a mode that defined the active region of scan-out, the blanking period, and sync pulses. And the blanking period was to allow time for the electron gun to sweep back around. And so from that legacy then, as we moved to digital displays, we kept that same idea of a mode that described the active region and blanking regions and sync pulses, but digital displays are driven by protocols like TMDS and LVDS and DisplayPort. In many cases, digital displays can only accept a more fixed set of modes that are what they advertise in their EDID. Then to achieve any other desktop resolution, the GPU has to do some sort of scaling. So early on with all of that, GPUs developed fairly specific scalars in the digital display pipeline. So these scalars would take one resolution that we'd read from the X screen, scale that up to some other resolution, and then that's what would go out, the active region. So to users and clients in the X world, flat panel scaling looked something like we would validate one mode or what we'd call one mode, through APIs, through R&R and x86 vid mode and whichever other APIs. We'd say, okay, we're going to drive this mode, but really in practice we drive some other mode to the digital display device. Because the digital display device could only accept a limited set of modes, but to provide a larger list, we'd validate additional modes, but then implicitly do something else.
I don't know anybody else who does this.
Really?
No.
I've been told the Intel driver does this. No?
Sometimes on LVDS.
Okay.
Yeah, the only time other X drivers scale is for internal panels that have a mode, and then we'll scale to whatever mode you have. But for external displays, we only ever use the EDID reported modes.
Okay, good.
Because?
Yes, because of the problems it causes.
Yeah.
Yeah. Okay, well, good. So I'm glad we're more on the same page. So so this would cause a variety of confusion. For example, on-screen displays reporting something different than what is reported through the API to the user. Worst case, refresh rates may not agree. And then how do you choose which, if a display device says I support these three modes in the EDID, and you're implicitly converting to one of those modes, how do you choose which one inside the driver? You don't really want to have that sort of policy baked in there. You might want to use different modes from the EDID. For example, regular 60 hertz versus a special stereo 120 hertz mode. And there's various examples of this sort of confusion online. So overscan compensation ties into this a little bit, but briefly to define what that is. So TVs historically have had a bezel edge around the glass, around the image. For a lot of traditional video content, maybe the content around the edge is not that important, and so if that bezel is covering up the edge of your video content, maybe you're not losing very much. And so TVs would often overscan, spilling their content behind that bezel. But if you're using a TV to display your normal desktop, that content around the edges is more important, and so you don't want that spill. So to accommodate that, drivers need to provide some sort of overscan compensation where we shrink the content such that nothing is hidden behind that bezel. And so we can do that either by downscaling the content, say the content initially is 1920 by 1080, and we're going to have like a 10 pixel border on all 4 sides, and we'll scale that content down to 1900 by 1060, or what? Yeah, yes, incurring all kinds of filtering artifacts. Yes, or change the size of your content.
And that's what X-ray is.
Yes. Okay, and then another category somewhat related is dealing with aspect ratios. You've got your content at one aspect ratio, the mode that your monitor is displaying is a different aspect ratio, and you may letterbox or pillar box to match the aspect ratio of the content that you're displaying. Over time, the scaling capabilities of hardware evolved. I know for NVIDIA GPUs, and I assume for most other hardware now, scaling is much more flexible, and you can scale, with NVIDIA hardware, we can scale any output protocol, and both upscale and downscale. And you can't do that on Intel? Yeah?
I don't think we
Yeah,
can upscale.
okay. You're missing out.
Both have bigger screens.
Okay, so in this model, in the most general sense, we really have 4 different resolutions to deal with. We have the size of the X screen, we have the size of what I'll call the viewport in, that's fetching some region of that X screen. We have what I'll call the viewport out, that is taking that viewport in content and putting it somewhere in the active region, and then we have the active region itself. These are the hardware capabilities that we would use for sort of any sort of flat panel scaling, or overscan compensation, or aspect ratio configuration. At one point in the NVIDIA proprietary driver, we would do implicit flat panel scaling and causing the kinds of problems that I mentioned earlier. And so we tried to move away from that, and given the context of the previous slide with with the very flexible viewport in and viewport out, it'd be nice to give that flexibility to users. And then another problem with sort of implicit scaling is that it encodes some amount of policy. You have to pick what sort of scaling configurations you're going to allow, whether you just always scale to the full resolution, full active region of the mode.
Yeah, I don't see anything here which isn't already provided in the Randor protocol,
Agreed.
which is all driver specific down at the bottom.
Yeah. No, let me keep going.
Okay.
Okay. So you don't want to bake in any more policy than necessary, and so we want to be sure that we decouple scaling configuration from the mode, avoid having multiple knobs, so having a way to do flat panel scaling in addition to any sort of other viewport configuration. The two would step on each other, and you want to avoid that. And so the solution is to make that configuration of how you're going to use viewport in and viewport out sort of meta information that's outside of here's the mode itself that you're going to use. And reasonable defaults, I think what we probably all do today, the viewport out, you're driving defaults to the size of your active region. By default, your viewport in would default to the resolution of your viewport out. And then when you're trying to pick your X screen at X server start time, defaulting that to the viewport in size that you have. With NVIDIA's meta mode syntax, first you can specify the mode and then optionally specify what viewport out and viewport in you'd like with that. With R&R, like Keith noted, you can do that today. So you specify the mode that you want.
You can do whatever you want.
Oh, sure. And the scale option is just a more is a user-friendly version of expressing the transformation matrix. So the border defines lets you specify a viewport out that's different than the active region, and then the scale or transform lets you define a viewport in that's different than the viewport out. So all those building blocks are there today, though they're maybe not the most user-friendly as is. The scale option is somewhat better than just the raw transform, but we can probably build better tools on top of that. One question is, how does this interact with flat panel scaling? And so in the NVIDIA driver, we just eliminated flat panel scaling entirely. I guess on Intel, if you say you do flat panel scaling for LVDS, I guess how does that interact with transform?
Well, for the LVDS case, we actually list a bunch of fake modes. And so we have exactly the same problem we have with external monitors, except that we have the correct refresh rates, because the fake modes that we construct have the same refresh rate. So we have a list in our driver of fake modes that we construct.
Okay.
And so, the question is whether using the hardware scaler or the software scaler, and it would be nice to get rid of the distinction and have the hardware used where possible.
Yeah. Okay. And so, like I think Keith mentioned earlier, if you limit the mode pool to just the EDID modes, you potentially end up with a fairly small list. When we made this transition, a lot of users complained. So how do we solve that problem? With all this flexibility, you can configure whatever random viewport configuration you want. But then the possible resolutions you can achieve with that are somewhat arbitrary. And so, for tools trying to build on top of this, if the panel supports only 1 or 2 or 3 resolutions, but you want to provide a more complete mode list to the user or to a full screen application who wants, say, 800 by 600, how do you decide, or who should decide what that list of resolutions should be? And I think on the wine mailing list at some point, I tried to argue that the application should make that decision. And they weren't too into that. And so I guess it was the discussion on the wine mailing list a while ago that partially motivated bringing this up here. I guess if we wanted somewhere to encode the policy about what resolutions should be advertised up the stack, taking advantage of this flexible viewport configurability that we have. Where does that belong? And I don't know if there should be some sort of utility library that encapsulates that things like wine and maybe STL and maybe different control panels doing display configuration. If it would be reasonable for those sorts of applications to use some utility library, and then that utility library might have a configuration file that would define resolutions that should be advertised or how that policy should be managed. But just bring it up here. I guess a few suggestions I'll offer. So honoring the border R&R output property, and offhand, I'm not sure what other drivers honor that, or if everyone does today. But to be able to specify a viewport in that's smaller, a viewport out that's smaller than your active region, so you can do aspect scaling configuration or overscan compensation, and then where possible, taking advantage of the display hardware to honor the transformation matrices specified through R&R. And then again, I don't know if it makes sense to define some sort of utility library that would abstract away policy that applications like wine don't want to encode themselves, but that don't really make sense lower in the stack either. I'll just leave that as an open question. And that's all I have. Okay, if there are any comments or thoughts? Okay, well, thank you.